So here was the uncus, here's that bump, and you see deep to that is this large homogeneous area, there's no definition to it, is the amygdaloid complex. And behind it you see this squiggly area right here is the very rostral end of the hippocampal formation. Okay? The other thing that you can see is this long strip of fibers right here, running back like that. Those are the inferior most parts of those geniculocalcarein fibers, which are the Myers loop fibers. So that's those fibers right there. Okay? So if we put this all back together, we should be able to then go through this at each level and kind of follow those structures. The next thing we want to do is we want to be able to take a coronal cut that then somewhat mirrors slide 10. And again, we're going to start at that interventricular foramen, or since we don't know where that is, we're going to start at the anterior pole of the thalamus. So again, here's another brain. Again, septum pellucidum isn't there. We'll get rid of anterior cerebral artery. Rid of that. So here's the anterior pole of the thalamus. If we go in here and pull off internal carotid artery, here's the uncus, or that bump, that rostralmost bump of periapicampal gyrus. Here's periapicampal gyrus coming around to become cingulate gyrus. Here's the marginal sulcus, paracentral lobule. Okay? So now we're going to make a coronal cut through what would be the interventricular foramen, but we don't have that, so I'm going to use the anterior pole of the thalamus, and through the uncus. First thing we want to do is this. If we come from the midline at the interventricular foramen of the anterior pole of the thalamus, we go through the genu of the internal capsule where it comes to the ventricular surface, and then we cut through the internal capsule and then through the lentiform nucleus. So right here was our point that we used, and we cut through there as internal capsule right to the ventricular surface. And here you can see the lentiform nucleus in coronal section, and you can see different colors. As you can see, this more putty color here and this pinker color right here is the difference between putamen and globus pallidus. Okay? When we look inside of the uncus, here's that same homogeneous region with none of the jelly roll look to it. Here's the amygdaloid complex. Okay? Now if we make a cut back here, go a centimeter back, we should cut through the thalamus, the posterior limb of the internal capsule, and the caudal part of the putamen. So if we do that, thalamus, posterior limb of the internal capsule, putamen. But now look, as we no longer have that amygdala, we don't have that homogeneous region, now we have that jelly roll look. Now we're in the hippocampal formation. So the amygdala only lies in about a centimeter at the very rostral end of the periapicammal gyrus, and then caudal to that is the hippocampal formation. Okay? But again, both of them involve consolidation of memory. One for emotion, one for more the explicit thoughts. Okay? Facts. All right? Here you can kind of see the continuation of the posterior limb of the internal capsule to now become the cerebral peduncle. Okay? If we make one more cut caudal to that, so now we're cutting back here through the thalamus, and internal capsule, but no longer any putamen left. So here's the posterior part of the thalamus and internal capsule. Still have hippocampal formation down here, and here you can just see the beginning of the lateral geniculate nucleus. It always has this sort of little Napoleon hat kind of looking structure, kind of a deal, okay? Now, what do you need to do with all of this? You need to be able to look at those and say, what are those structures? And give a general function to them. What's traveling through the internal capsule. You should be able to look at this and look at the horizontal and say, what is the blood supply to any one of these regions? So when we look at this, remember, we're looking at anterior cerebral artery back to the parieto-occipital sulcus, and then posterior cerebral artery on this inferior part of the temporal lobe going down. And then all of this on the outside is middle cerebral artery. So in a coronal section, anterior cerebral artery on the midline, posterior cerebral artery on the inferior part of the temporal lobe, and all of this lateral surface is middle cerebral artery. Okay?
So you've got your columns, your medullary columns, and then the olive on either side. So 9, 10, and 11 come out from behind you, olives, and 12.
Okay, so the last thing is the cerebellum. Okay, so let me do this one. Here's the cerebellum. Now, the cerebellum can be divided anatomically, but we didn't do that. We divided it into 3 divisions called functional divisions. Okay? When we look at the divisions, the majority of all of these, this is called the lateral hemispheres. And that is all cerebrocerebellum. In other words, that's the part of the cerebellum that's getting information from cortex by way of relay nuclei within the pons. Okay? Those fibers travel from cortex through the cerebral peduncles to get to the pons, along with corticospinal and corticobulbar fibers. Okay? So that's cerebrocerebellum. Then we have this midline, inferiorly or posteriorly, we have this midline groove that then becomes sort of this midline ridge. And that's the vermis. And on either side of the vermis is something referred to as the paravermal zone. And then you can't really tell where that is, but just around here. That paravermal zone plus the vermis is the spinocerebellum. It's more attuned to receiving information from dorsal spinal cerebellar tract, cuneo-cerebellar tract, and really the specific components of spinal cord activity. Okay? And then finally, the last component is the vestibulocerebellum, and that's represented by this small piece that's stuck out here to the side, and that's the flocculus. So there's a flocculus on this side and a flocculus on this side. And then when we look at the midline component, here's the vermis right here, and all of this is spinocerebellum until you get to this very last piece right here, which is the nodule. And the combination of the flocculus on both sides plus the nodule is the vestibulocerebellum. Okay? Now remember that each one of those functional divisions was defined according to kind of what part of movement, what part of the central nervous system it really had some control and relationship with. But the output of all of that cerebellum was by way of deep cerebellar nuclei. So then what I did was I took this cerebellum and I cut it. And I shaved off the top of it to the point that we could now look at the internal structures. So on this side, what you can see is this darkened area right here, and that's the dentate nucleus. So that's representing the deep cerebellar nuclei specific for cerebrocerebellum. And you can't see the others. You can't see interposed or fastigial nucleus. But what you can see out of that is the fibers that are leaving there and heading towards the midbrain, which is the superior cerebellar peduncle. Okay? So primarily an efferent pathway. Then I shaved off a little bit more on either